Now we got to go back a ways. Multiplying and dividing rational expressions. Basically, all we're doing is rational expressions are fractions. Rational means a fraction. Expressions means we have letters in them. All right. But if we go way back, multiplying and dividing fractions, we've done before, and it was the easiest thing to do. And if you remember back then, we learned how to multiply and divide before we learned how to add and subtract, because it was a little bit easier. And the fact that you have to know how to multiply in order to find that common denominator. And what you do to the bottom, you then again do to the top to make them equivalent. All right. So we have the rules for multiplying and dividing fractions. So if we bounce back, let's give me a different color here. Multiplying fractions is simply tops times tops, bottoms times bottoms, and of course it's a fraction, so we look to reduce. When we divide, dividing is what we termed copy the first fraction, dot the operation, and flip, all right, or keep dot change, or whatever your terminology your classroom teachers in high school or whatever taught you is correct as well. Multiply by the reciprocal is the same thing. But those are the things that I taught you guys in class. So the rest of this is just now tying in the expressions part and how to do that. So we're going to be doing a few examples. So let's get to that. Let's say we have multiplying two fractions. One is 2c plus d all over 3 and times 18 over 6 c plus d. Let me get that a little bit better for us if I can. That's up. There we go. Plus d, and that guy is squared. All right, so immediately we can just go through and tops times tops, bottoms times bottoms, reduce. But we can reduce before that. So let's just reduce here. I can get those guys gone, and I get 3 over 1, right? If I look again, I can go, this guy reduces with that guy, and I get 1 over 1. Well, my numbers now are reduced. I have more quantities of c plus d on the bottom by 1, so there goes the exponent, and there goes this entire guy, right? Whoops, wherever he went. Ran off my board over here, got too excited or something. And then I just simply tops times tops, bottoms times bottoms. So everything over here in the tops of 1 times 2 gets me 2. Everything over here is a 1 times 1 is just 1, and then I have this c plus d on the bottom, which is just c plus d. So I end up with a quantity of 2 over the quantity of c plus d. And that is my reduced. So tops times tops, bottoms times bottoms, and I can reduce before, which makes it a little bit easier. This next problem is a little bit more difficult just because it's tricky. All right, so I need to do one of these for you. 8 divided by, and this is t minus 2 over 6. Well, we're dividing, so it's copy dot flip. And so it's copy dot and 6 over t minus 2. Well, this guy becomes fairly easy to see that I can get a 2 at least out of that guy, which leaves me with a 3 here and a 4 there. But this guy and this guy are not the same. This is a positive 2 and a negative t. This is a positive t and a negative 2. Well, if we take that, I'm going to extract that and show you real quick what's going on there. So I'm going to take this guy. Doesn't really matter which one, but usually we're used to having our coefficients or our letters in front and our numbers behind. So I'm going to take this 2 minus t. I'm going to make it minus t plus 2. And what you're going to see is now my order is the same. My signs are off. So I can actually take this negative 1 out, and I get t minus 2. So if I do that, pull that back in here, so I have a negative 1, t minus 2. My t minus 2's reduce, and I get left with a negative 1 times 3 up top, which is a negative 3, 4, and this guy, whoop, I forgot to put the 1, would have been 4. And remember in your book, on top or in front, it's the same thing. If the negative falls below, it's not the same thing. So either one of those answers I would accept in there. But this is kind of be careful of this guy, because this guy is kind of a goofy guy, because you can factor out that -1. Make sure the order works. Make sure you can factor in -1. Make sure you pull it out of both terms. Let's do another one. Got a little bit of length to it here. Let's go 2x squared minus 7x plus 3. Let's take that all over x minus 3. And let's times it by x plus 2, x plus 1. Well, you look at this and go, oh, yeah, that foils. Well, that's great. But if I try to distribute this up top, I'm going to get something huge. And then to try to reduce that is going to be a pain in the butt. So let's break this guy, see at least if this guy factors, and we'll break that guy down. Okay, so I'm going to turn it to blue here real quick. 2 times 3 is 6. 2 factors that add to get -7 are both -1 and -6. So I know that it factors. So what does it factor to? I have to go to 2x squared minus x minus 6x plus 3. So I'm expanding that middle term, factor by grouping. So I'm going to group always my first 2 terms and my last 2 terms. I can pull an x out of both of those. I get a 2x minus 1. And then I want a positive 2x here, so I'll factor out -3 there. And when I do, I get 2x. Factor out that -3, I get a -1. So I get a 2x minus 1 and an x minus 3. All right, so I'm going to take this, I'm going to put it back up here in this problem. I'm going to substitute it in for this guy. So 2x minus 1 and x minus 3. Well, as you can see right there, there comes that x minus 3 out, which we'd have never found had we just multiplied this trinomial times that binomial. Everything else stays the same, right? So that guy was 1, this guy was 1, which means now I just tops times tops, which is 2x minus 1, x plus 2, all over 1 times x plus 1, which is just x plus 1. And I can actually leave it for right now. I'm going to leave it, this section, leave it as factored terms. Let's do one more, because I know you're all dying to do more. Let's go m squared plus 2mp minus 3p squared all over m squared minus 3mp plus 2p squared. We're going to divide that. On top is m squared plus 4mp plus 3p squared. And on the bottom I have m squared plus 2mp minus 8p squared. All right, so as you can see, we got a lot of factoring to do. So I'm going to factor this guy, and they're all great because they're all coefficient terms of 1. So I can just do that from right here. So let's turn it blue so we know kind of the difference of what's going on here. Okay, this has to be an m, that has to be an m. I have to have a p on the back side to get that p squared. 2 factors of 3 that get me 2 or 1 and 3. The sign of the larger has to be positive. So there's how that guy factors, m minus p and m plus 3p. So let's just go down here. And this guy goes to m and m, p and p. 2 factors of 2 are just 1 and 2. They both have to be the same sign. They both have to be negative. And as you can see, okay, all of a sudden I've got this guy reduces with that guy. All right, yes, that guy reduces. But let's not reduce quite yet. Let's go ahead and get this guy. Now this guy, I can go ahead and factor and put my terms above here. I'm not going to do that. I'm going to go ahead and flip this guy. Okay, so because I'm kind of thinking ahead, right? I can kind of miss a few steps. So this guy goes up there now. And when it does, I can go M, P, M, P, 2 factors of 8 to come out to 2, or 2 and 4. Opposite sign, sign of the larger has to be positive. So I have an M minus 2P and an M plus 4P. And now, don't forget to flip this guy. This guy goes down here, which means 2 factors, M and P to get the M squared up front, the P in the back, 2 factors of 3, or 3 and 1. They both have to be the same sign. They both have to be positive. And now I'm looking at the blue terms. There goes an M minus 1P, and all it is matching at this point in time. Here comes an M minus 3P. There goes an M minus 2P, which means everything over on the left side is reduced. Anything on the right side, it says, is just this M plus 4P. So M plus 4P all over M plus P. And that would be my answer. And yes, there could be a time when we do all this stuff and nothing reduces. So you just have four factors across the top and 4 factors across the bottom. There could be a time where everything reduces. And if everything were to reduce, please understand, if everything reduces, something divided by itself will always be 1. So your answer could come out to 1 here as well.